Welcome back, everyone. Ready to dive into some cutting-edge research?
Absolutely. Always exciting to see what's new in the world of security and AI.
We've got 26 articles from our CIVA security section, all published on January 31st, 2025.
A great mix. Blockchain security, AI-powered attacks and defenses, even some brainwave biometrics.
Lots to unpack. Blockchain to brainwaves. Let's start with the Internet of Things, specifically security for IEEE P1451.1.6-based sensor networks for IoT applications.
Catchy title, right? But seriously, it's about securing the massive network of devices that make up the IoT.
The IEEE, that's the Institute of Electrical and Electronics Engineers, right? They develop
Mhm.
standards for all sorts of tech.
Exactly. And in the IoT world, those standards are crucial. This research proposes a new solution for making sure only authorized devices and users can access sensitive data within those networks.
So it's not just about protecting individual devices, but about securing the entire ecosystem. What makes this solution so different?
It builds on something called IEEE P1451.1.0. It's a framework for sensor communication. This new research adds a service for dynamically updating access control lists.
Dynamically updating. So the security policies can adapt in real time.
Imagine a smart city network, sensors everywhere. As new devices come online, the access control lists adjust automatically to maintain security. No manual intervention needed.
Now that's a smart system. Okay, let's shift gears to AI. We've got a couple of articles here that really highlight how it's being used on both sides of the cybersecurity battlefield.
Absolutely, it's a constant arms race.
On the defense side, we have entropy-synchronized neural hashing for unsupervised ransomware detection. Sounds intense.
It is. Ransomware is a huge problem. This research offers a new way to detect it, even when attackers try to hide it with obfuscation techniques.
Obfuscation.
Basically making the code really hard to read and understand. A lot of ransomware detection relies on signature-based approaches, which can be easily bypassed. This new method takes a different approach.
Okay, I'm intrigued. How does it work?
It analyzes the entropy characteristics of the software binaries.
Entropy.
It's a measure of randomness or disorder. Every software program has a unique entropy profile, kind of like a fingerprint. This research uses neural hashing to create a model that can recognize the entropy patterns associated with ransomware.
So even if the code is obfuscated, you can still spot the telltale signs of ransomware based on its entropy.
Exactly. It's a more proactive and robust approach.
Okay, so that's the defense side. Now let's talk about how AI is being weaponized.
Guard Reasoner. Towards reasoning-based LLM safeguards tackles a very important issue: the safety and reliability of large language models, or LLMs.
Those are the AI systems behind things like ChatGPT and Bard, right?
Exactly. Incredibly powerful, but they can be vulnerable to manipulation, especially in critical applications where safety is paramount.
Right. So it's not just about preventing hacking, but also about making sure these LLMs don't accidentally cause harm.
This research proposes developing guard models. They act as a sort of safeguard for LLMs, trained to reason about the potential consequences of an LLM's actions and step in if they detect a risk.
It's like giving AI an ethical compass.
Exactly. And it's a really interesting area of research, especially as these LLMs become more integrated into our lives.
Okay, let's move on to the world of cryptocurrency and blockchain technology. We've got two articles that give us a glimpse into some really interesting applications.
The first one, Large Language Models for Cryptocurrency Transaction Analysis, a Bitcoin case study, explores a new way to analyze Bitcoin transactions.
I'm guessing it involves LLMs.
You got it. They're not just looking at tracking the flow of funds, they're trying to understand the underlying behavior patterns in a way that's more understandable to us humans.
So instead of just seeing a bunch of transactions, you can actually get insights into the motivations and strategies of the actors involved.
Imagine being able to identify suspicious activity, market trends, even predict future behavior based on the language of crypto transactions.
Pretty powerful stuff. Now, how does the other article have measuring blockchain decentralization tie into this?
This one tackles a fundamental challenge in the blockchain world: how to actually measure decentralization.
Which is like the whole point of blockchain, right?
Exactly.
Good.
But it's complex. This research digs into different methodologies for measuring decentralization. It's about making sure those systems live up to the promise of decentralization.
Moving from promises to actual metrics. Love
Yeah.
it. Okay, let's talk cryptography and authentication. We've got a couple of articles that caught my eye.
Starting with author. Lower cost authenticity-oriented garbling for arbitrary Boolean circuits. This one introduces a new scheme for verifying the authenticity of messages or data.
Okay, break that down for me. What is authenticity-oriented garbling?
Think of it like sending a sensitive document electronically. You want to make sure no one tampered with it along the way. Traditional barbling schemes encrypt everything, the document, the computation, the whole 9 yards. It's very secure, but also computationally expensive.
So this new scheme is about making that process more efficient.
Exactly. It focuses specifically on verifying authenticity, not encrypting everything. It's like adding a tamper-proof seal to the document instead of locking it in a vault.
So, same level of security, but with less overhead.
Mm.
Nice. Now, let's get to something totally different. Brainwave biometrics.
Advancing brainwave-based biometrics, a large-scale multi-session evaluation. It's a fascinating look at using brainwave patterns for user authentication.
Wait, brainwaves? How can those be used for authentication? They're constantly changing.
Right, but this research shows that there are still underlying neural signatures that are consistent enough for individual identification.
Really? Like recognizing a song, even if the tempo or instrumentation changes?
Perfect analogy. They use deep learning to identify those individual brainwave melodies.
So you could potentially unlock your phone with your thoughts.
Maybe someday. There's still a long way to go, but this research shows that brainwave biometrics have potential.
It's both exciting and a little unsettling. Okay, let's move on to AI-generated content. It seems like every day there's a new tool or platform popping up. But with those opportunities come new challenges.
Absolutely. Bound to say A. A CAP-TA utilizing boundary identification in AI extended videos is a perfect example. It's all about the ongoing battle between CAP-TCHAs and AI-powered bots.
Ah, yes, CAP-TCAs, those annoying puzzles we have to solve to prove we're not robots. And the bots are getting better at solving them all the time.
This research introduces a new kind of CAP-TTH. It uses AI to create a CAP-TCA that's harder for AI to solve.
So they're fighting fire with fire.
In a way, they're exploiting the fact that AI systems still struggle with identifying subtle boundaries in videos, things that are easy for humans to see.
So the CAP-TCH might be something like identify the frame where the scene changes or spot the glitch in the animation.
Something like that. It's a constant arms race, but this research is a step forward in making CAP-TCH is more human-friendly and bot-resistant.
Now let's talk about another challenge, copyright infringement. Plug-in authorization for human content. Copyright protection in text-to-image model dives into this tricky issue in the context of AI-generated images.
It's a really important topic. This research proposes a framework for protecting copyright in the age of AI. The idea is to create plugins that act as permissions for using specific copyrighted material in AI models.
So instead of an AI just copying any style it encounters, it would need authorization, like a digital handshake.
Exactly. Imagine a system where artists can register their work and control how it's used by AI. If an AI wants to generate an image in a particular artist's style, it needs to get a plugin for that artist's work.
That makes a lot of sense. A way to protect the rights of human creators while still allowing for the creative potential of AI. Okay, moving on to healthcare security, always a critical area.
CryptoDNA, a machine learning paradigm for DDoS detection in healthcare IoT inspired by cryptojacking prevention models, is all about protecting healthcare IoT devices from DDoS attacks.
DDoS attacks can be devastating, especially in healthcare where lives are at stake.
Absolutely. This research takes inspiration from techniques used to detect cryptojacking. That's where attackers secretly use your computer to mine cryptocurrency.
Interesting. So what's the connection between cryptojacking and DDoS attacks?
Both involve unusual patterns of resource usage and network activity. CryptoDNA leverages that similarity. It uses machine learning to analyze behavioral patterns in healthcare IoT networks and look for anomalies that could indicate a DDoS attack in progress.
So it's all about being proactive and catching those attacks early on. Smart approach. Okay, let's talk about something that's not often discussed. Cache occupancy attacks.
Systematic evaluation of randomized cache designs against cache occupancy. This one dives into a vulnerability that's often overlooked. Caches are those temporary storage areas that hold frequently accessed data. Cache occupancy attacks exploit vulnerabilities in how that data is stored and retrieved.
It's not about stealing data, but about messing with how the system accesses it.
Right. This research tests different cache designs to see how well they resist these attacks. And they considered some pretty serious threat models, like covert channels, process fingerprinting, even AES key recovery.
AES key recovery, that's a big deal.
It highlights just how important secure cache design is for overall system security.
Like, ready for another topic shift? Let's talk about software security and the challenges of securing our increasingly complex and connected systems.
Sounds good. Gotta detect them all. Fake base station and multi-step attack detection in cellular networks focuses on a growing threat to mobile devices.
Or
Fake base
fake
stations.
base station. Sounds like something out of a spy movie.
They're real, and they're dangerous. Attackers can set up these fake cell towers that look like legitimate ones, then they can intercept data from anyone who connects to them. This research introduces FBS Detector, a system that uses machine learning to analyze network traffic and identify the telltale signs of a fake base station.
So it's like a digital detective sniffing out those fake towers.
And it can also detect multi-step attacks.
Multi-step. What's that?
Attacks that unfold in stages. Each step is designed to avoid detection. Think of it like a hacker, first using a fake base station to gather intel and then using that info to launch a phishing attack. FBS Detector can spot these patterns and raise an alert.
Very cool. And essential in today's hyper-connected world.
Okay, let's wrap up this section with a look at provenance.
Establishing provenance before coding. Traditional and next-gen software signing. It's all about verifying the origins of software components. We need to know that the software we're using comes from a trusted source.
Especially with all the supply chain attacks we've been seeing lately. Hackers are getting more and more sophisticated.
Exactly. This research looks at how traditional and next-generation software signing practices can be used to create a sort of chain of custody for software. That way, we can be sure that the code hasn't been tampered with along the way. Makes sense. Kind of like a digital signature that verifies the authenticity of the software. Okay, let's take a quick break, and then we'll be back to explore even more fascinating research. Welcome back, everyone. We're diving deep into 26 cutting-edge research articles from the security section of RCAF, all published on January 31st, 2025.
We left off talking about software supply chains and making sure we can trust where our software is coming from.
Right. It's all about provenance, knowing the origins of software components and making sure they haven't been tampered with.
It's essential for building trust in the software we use, especially with the rise of supply chain attacks.
So let's talk AI security. We've got a couple of articles here that really highlight the evolving threat landscape in this area.
AI is becoming a powerful tool for both attackers and defenders. It's a constant arms race.
The first article, here comes the AI worm, unleashing zero-click worms that target Gen AI-powered applications. Sounds pretty ominous. Worms. Haven't heard that word in a while.
They're back, but with an AI twist. This research introduces Morse II, a new type of AI-powered worm that targets Gen AI applications.
Gen AI.
Generative AI. Think chatbots, content creation tools, things like that.
Okay, so how does this AI worm work? What makes it different from traditional worms?
Morse II exploits a vulnerability in how these Gen AI applications use something called retrieval augmented generation, or RAG. It's how they pull in information from external sources to answer questions or generate content. Morse II basically crafts these adversarial prompts that trigger a chain reaction of prompt injections. It spreads itself like a virus through the Gen AI ecosystem.
Adversarial prompts. Prompt injections.
It's a way of manipulating the AI's input to make it do something it's not supposed to do. In this case, spread the worm.
Wow. So it's like an AI virus.
In a sense. And it raises serious concerns about the security of these Gen AI applications, especially as they become more integrated into our lives.
The researchers did propose a solution, though, right?
Yes, they call it Virtual Donkey. It's a guardrail designed to detect and block the propagation of Morse II without disrupting legitimate use of the application.
Okay, so there's hope. What about the other article, How to Backdoor Consistency Models? That sounds pretty scary, too.
Backdooring an AI model is basically inserting a hidden vulnerability that can be triggered later to make the model behave maliciously. This research focuses on backdooring consistency models, which are a new class of image generation models.
Image generation.
Yeah.
So even AI models designed for seemingly harmless tasks can be weaponized.
This research shows how it's possible. They developed an attack framework that uses random noise as a trigger for the backdoor.
Random noise. Why random noise?
It makes the backdoor harder to detect. It's like hiding a secret message in static. When the poison model encounters the specific noise pattern, it produces a predetermined target image, effectively hijacking the model's output.
That's really unsettling. It's like a sleeper agent embedded in the AI.
It highlights the need for robust security measures throughout the entire AI lifecycle, from training to deployment. We can't just assume these models are safe.
Okay, let's shift gears now and talk about something fundamental to scientific research. Reproducibility. Being able to replicate research findings is essential for building trust and validating results.
Absolutely. We have two articles here that address the challenges of reproducibility in different ways.
The first one, Web Execution Bundles. Reproducible Accurate and archivable web measurements focuses on web measurements.
Think things like user behavior, website performance, security vulnerabilities, all sorts of data that's collected from the web. It's crucial for understanding how the web works and making it better, but reproducing those measurements can be tricky.
What are some of the challenges?
Existing tools are often inaccurate, incomplete, or not portable enough to share easily. This research introduces WebRec, a new tool designed to address these limitations. It also proposes a new archival format called .web for storing and sharing web measurements.
So it's about making web research more rigorous and transparent.
Exactly.
What about the second article? Stack Overflow meets replication. Security research amid evolving code snippets. Extended version. This one sounds intriguing. Stack Overflow. That's where programmers go to ask and answer coding questions, right?
Right, it's a huge online community. And researchers often use code snippets from Stack Overflow in their work. But code is constantly evolving. What worked a year ago might be outdated or even contain vulnerabilities now.
So relying on these static code snippets can actually undermine the reproducibility of research findings.
Exactly. This research highlights the importance of treating Stack Overflow as a dynamic data source. They recommend using version control systems and carefully documenting the specific versions of code used in experiments to ensure reproducibility.
It's a good reminder that even seemingly stable resources like code repositories are constantly changing. Researchers need to be aware of that. Okay, let's move on to the topic of privacy, which is more important than ever in our data-driven world.
We have an article here that caught my eye. Optimal survey design for private mean estimation. It addresses the challenge of collecting data through surveys while protecting the privacy of individual respondents.
Surveys are everywhere, and they often collect sensitive personal information. How can we make sure the data is protected?
This research explores different survey design techniques, specifically focusing on stratified sampling. It's a way to divide a population into subgroups and then randomly sample from each group.
So you get a representative sample without collecting too much data from any one individual.
Exactly. And by combining this with privacy-preserving mechanisms like differential privacy, they can minimize the risk of identifying individuals while still obtaining accurate results.
Differential privacy, that's the technique that adds a bit of noise to the data to make it harder to re-identify individuals, right?
Hey, it's a trade-off between accuracy and privacy, but this research shows how to optimize that trade-off to get the best of both worlds.
Very cool. It's great to see researchers working on these practical solutions to protect privacy in our data-driven world. Okay, ready for something a little more mind-bending.
Let's talk about zero-knowledge proofs. Experimental relativistic zero-knowledge proofs with unconditional security dives into this fascinating area of cryptography.
Zero-knowledge truth sounds like something out of a sci-fi novel.
It's a way to prove, something without revealing the information itself. Imagine proving you have a winning lottery ticket without showing anyone the numbers.
That's amazing. How is that even possible?
This research uses principles of special relativity and quantum non-locality to create these unbreakable proofs. Even with unlimited computing power, you can't extract the underlying information from the proof itself. It's mind-blowing stuff.
So what are the real-world applications of this?
Think secure voting systems, anonymous authentication protocols, anything where you need to prove something without revealing sensitive information. This research opens up some incredible possibilities.
It sounds like we're on the verge of a whole new era of privacy and security. Okay, let's wrap up this section with a look at healthcare privacy.
FLSFHE, a heterogeneous architecture for fully homomorphic encryption acceleration, explores the use of fully homomorphic encryption, or FHE, to protect sensitive patient information.
FHE. That's the encryption technique that lets you perform computations on encrypted data without ever decrypting it, right?
You got it. It's like magic. You can process sensitive medical records without ever exposing the raw data.
But isn't FHE really computationally expensive? Like, too slow for real-world applications?
It has been a barrier to adoption, but this research introduces Flash FHE, a hardware accelerator designed specifically for FHE. It significantly speeds up performance, making FHE more practical for real-world healthcare applications.
So they're basically building specialized hardware that can handle the heavy lifting of FHE.
Exactly. It's a huge step forward in making FHE a viable option for protecting patient privacy. So we've talked about securing data at rest and data in transit, but what about data that's being processed That's where FHE comes
All
in.
right, fully homomorphic encryption. It's like a privacy superhero. It lets you perform computations on encrypted data without ever decrypting it.
Exactly. And that's a game changer for privacy sensitive applications, especially in healthcare.
But as we mentioned before, FHE can be computationally expensive. It's a barrier to wider adoption.
This research, Flash FHE, a heterogeneous architecture for fully homomorphic encryption acceleration, tackles that challenge head on. They've developed a hardware accelerator specifically designed to speed up FHE.
So they're basically building specialized hardware that can handle the heavy lifting of FHE, making it faster and more efficient.
Exactly. It's a big step forward in making FHE a practical solution for protecting patient privacy in real-world healthcare settings.
This has been an amazing journey through the latest advancements in security and AI. From securing the Internet of Things to the potential of brainwave biometrics, the evolving landscape of AI security, and the importance of reproducibility and privacy, we've covered a lot of ground.
It's incredible to see the pace of innovation in these fields, and it's inspiring to see so many brilliant minds working to create a more secure, private, and trustworthy digital world.
It's definitely a lot to take in, but it's also incredibly exciting. It's clear that we're on the cusp of a new era in security and AI.
And it's more important than ever to stay informed and engaged in the conversations shaping our digital future.
Couldn't agree more. A huge thank you to our expert guests for sharing their insights today, and to all of you listening, we encourage you to explore the linked research articles for more information. Until next time, stay curious and stay safe.